Good evening, everyone. Today's topic for discussion will be properties of X-rays. Regarding this topic, the areas where you have to concentrate more are physical properties of X-rays and types of radiation being produced. These are the two areas where MCQs are being repeatedly asked. So you have to concentrate more on these two topics. Okay, sir. To start with the definition of X-rays, X-rays are defined as weightless packages of pure energy, that is the photons. They have no electrical charge and they travel in waves along with the straight line with a specific frequency and speed. The important points to be taken are X-rays have only energy. They don't have any charge or they don't possess any weight. They travel in straight lines with a specific frequency and a speed. As we have seen in the electromagnetic spectrum, X-rays are present before the gamma rays. So they have a short wavelength and the high energy. So they has the tendency of penetration property that is being used in diagnostic radiology. The properties of X-rays may be classified into four broad categories, that is physical, chemical, biological, and physiochemical. To start with the physical properties of X-rays, the wavelength of X-rays have been asked as an MCQ many times. Just remember that the wavelength of X-rays falls between 10 Armstrong to 0.01 Armstrong units. They travel through the space in a wave motion in a straight line. They travel with the same speed as that of the visible light, that is 3 into 10 power 8 meter per second. And as they travel through the space, they can produce an electrical field at right angles to their path of propagation and magnetic field that is right angle to the produced electric field. They are basically invincible to the human eyes. They cannot be seen, heard, or smelled. That is, they remain undetected by the human senses. They cannot be focused by the lens. They cannot be reflected, refracted, or deflected by electric or magnetic field, as they do not possess any charge. Kindly remember, X-rays does not possess any charge. It does not possess any weight. It has only the frequencies and it travels with speed. They show the properties of interference, diffraction, and polarization that is similar to that of the visible light. They do not require any medium for propagation. They are one pure energy, with no mass, and they have the capability to transfer energy from one place to place in the form of quanta, that is the photons. In free space, they obey the inverse square law. For a point source of radiation, the intensity is inversely proportional to the distance from the source to the place. This we have already seen in the last class, and this also can be asked as an MCQ. The intensity will be inversely proportional to the square of the distance. And then these are the areas where you have to concentrate more, because repeatedly it has been asked as an MCQ. What is Bremsstrahlung radiation and what is characteristic radiation? Only one word difference will be seen in these two type of radiation. Bremsstrahlung radiation is a one in which the incoming electron penetrates the outer shell and they passes close to the nucleus. Here, the incident electron, here, this is the high energy incident electron. They either hit the nucleus or they will pass close to the nucleus, which results in electrons deflection and deceleration. This kind of radiation being produced is Bremsstrahlung radiation, and the other one is a characteristic radiation. Here, the incident electron ejects an photoelectron from an inner orbit, as we can see in the picture A. This is the high energy electron. It comes and ejects a photoelectron from an inner orbit, creating a vacancy, as we can see in the picture B. And this inner vacancy is filled with an electron from an outer orbit. And since the electron from an outer orbit comes to the inner orbit, photon is emitted with energy equal to the difference between equal to the difference in energy levels between of these two orbits, and this radiation is emitted in the form of photons, that is called as a characteristic radiation. We have different wavelength of X-rays ranging from 1 to 2 Armstrong to 0.01 Armstrong. Just remember the soft X-rays and the hard X-rays and their uses. The hard X-rays have a wavelength of about 0.1 Armstrong units. They have the maximum penetration power, so they are used in diagnostic radiology. Whereas the soft X-rays, they have the wavelength of between 1 to 0.5 Armstrong. They have minimum penetration power and they are used in therapeutic radiology in cases of cancer radiotherapy. Just remember the three properties like attenuation, absorption, and scattering. When passing through matter, the intensity of the radiation is reduced. That property is being called as an attenuation. It happens because of two other properties called absorption and scattering. Radiation energy is taken up by the material by the process of absorption, and some of the radiation is deflected back to its original path to travel in a new direction. That is called scattering, and any of these three properties can be asked as an MCQ. And this attenuation depends upon the thickness of the object. When the thickness of the object increases, the attenuation also increases. And if the atomic number of the matter increases, the attenuation also increases. Whereas regarding the photon energy, if the incident photon energy increases, there will be decrease in the attenuation for the given object, because there will be a conversion of their kinetic energy into energy of the observer electrons. These are the components of the body arranged in an increasing order of their power to absorb the X-rays, starting from the lowest value. That means air has the lowest value to absorb X-rays, and enamel has the highest power to absorb X-rays, that is more than the medullary cancellous cortical bone. And this can be asked as an MCQs. They'll just list out the four components of the body and they'll ask which has the maximum power to absorb the X-rays. Just remember, enamel has the highest power to absorb X-rays. Whereas the interaction of X-rays with matter occurs as a three processes like coherent scattering, photoelectric effect, and Compton scattering. As we can see in the picture, the incident photon coherent scattering results from the interaction of a low energy incident photon with an outer electron, causing it to vibrate momentarily. After this interaction, the scattered photon of the same energy, just remember, same energy is emitted at a different angle to the path of an incident electron. As we can see in the image here, an incident photon, it comes and interacts with an electron in the outer orbit, and then the scattered photon with the same energy is emitted at a different angle. This is coherent scattering. And second one is the photoelectric absorption. It occurs when an incident photon gives up all its energy to the inner electron. Here it comes and reacts with an inner electron that is being ejected from the atom as a photoelectron. Here it is being liberated as a high energy level electrons. And the third one is a Compton scattering. Compton absorption occurs when the incident photon interacts with an outer electron, resulting in a scattered photon of lower energy. Just remember, lower energy than that of an incident photon. And then recoil electron is ejected from the target atom. Coming to chemical properties, they have peculiar chemical properties like methylene blue gets bleached, and sodium platinosidate, which is basically apple green, it turns to darker shades, then light brown, and finally dark brown. And these color change properties are basically used to detect the cases of forgery and for the X-ray dose measurement. Coming to biological properties, when X-rays are incident on an atom, among the many reactions produced, one such is called as excitation. This is an important cause of biological damage that is produced by radiation. This property of excitation is used in the treatment of malignant lesions. And second one, the X-rays also have an germicidal or bactericidal effect and are used for the sterilization and preservation of food. The next biological properties of X-rays may be classified into two types. One is the somatic effect and the other is the genetic effect. The somatic effect, it basically ranges from a simple sunburn to severe dermatitis and even to the changes in a blood supply or even to malignancies. The somatic effect is basically cumulative, how much it receives, and it depends upon the type of tissue and the intensity of the radiation. And the second one is the genetic effect. This is basically due to the radiation induced mutation of genes and chromosomes, and which we are commonly encountering in Hiroshima and Nagasaki bomb blast cases. There, these effects are usually seen in the offsprings of irradiated parents. The fetus is more sensitive to radiation in the early stages of development. Coming to physiochemical properties, the photographic plate, X-rays turns the photographic plate to black. This blackening is called as an film density, whereas the difference between the degree of density is referred to as the film contrast. Just to remember these two topics, film density and film contrast, they can be asked as an MCQ. And finally, to sum up the diagnostic properties of X-rays, these X-rays travel in straight line. They can penetrate liquids, solids, and gases. The composition of the substance determines whether the X-rays can penetrate or it can be absorbed. X-rays can be absorbed by matter. The absorption depends upon the atomic number of the matter and the wavelength of X-ray. X-rays can interact with the materials, they can penetrate, they can cause ionization, or they can also dissociate silver ions in film emulsions. X-rays can cause substances to fluorescence or emit light radiation in longer wavelength. X-rays can produce an image on a photographic film. X-rays can cause biological changes in living cells. And now we'll see 3 MCQs. The first one, wavelength of X-rays ranges from, this is a direct question. The answer is option A, 10 Armstrong to 0.01 Armstrong units. They can even ask the wavelength of soft X-rays, the wavelength of hard X-rays, and they can also ask what are hard X-rays used for and what are soft X-rays used for. Hard X-rays are used for diagnostic radiology, soft X-rays are used in radiotherapy. Which of the following is not true about X-rays? They'll just list out any 4 of the physical properties of X-rays and they'll ask you to find the false one. The options are X-rays travel in straight line, X-rays are absorbed by matter, X-rays cannot produce an image on a photographic film, X-rays can cause biological changes in living cells. Option is C, X-rays cannot produce image on a photographic film, because that is the concept being used. X-rays, it can produce an image on a photographic film. A Bremsstrahlung radiation occurs when incoming electron penetrates the outer electron shell and passes close to the nucleus of the tungsten atom. And the incoming electron passes close to outer electron on the orbit, both of the above, none of the above. This is the difference between the 2 types of radiation. Just remember the word nucleus belongs to Bremsstrahlung radiation. The option is A. The incoming electron penetrates the outer electron shell and they pass close to the nucleus of the tungsten atom. Any doubts? Thank you all.